Now, like very popular topic that we're going to discuss now, which is external off-chip memories. So here you can see there mentioned few interfaces, right? Double data rate interfaces, right? DDR3, DDR3L, LPDDR3, LPDDR4, right? So that means our processor, which is RK3399, supports these many DDR interface only, right? If you'll go for DDR or earlier version of DDR, you can't able to integrate those because of some internal architecture or internal design of the system on chip level, right? So these many DDR interface which is supported. Now, so here I'm not going to discuss these only because this is like a very confusing topic and no one knows it fully, right? So I'm just going to discuss that from very scratch, like what are these things. So we'll start from what is single data rate. If we are talking about double data rate, that means there will be single data rate also, right? What is that? Anyone? Just guess. Like double data rate means something is twice, single data rate means something is...
The difference, I think, is with every one edge of a clock, there is data on the rising edge or the falling edge. Because maybe the single data rate, just with the rising edge or the falling edge, we will transfer data.
Correct.
Is that right?
Correct. Very right.
Yeah.
So again, as its name suggests, right, single data rate means, so here, like when we talk about DRAM interface or SDRAM interface, there are some data lines which is responsible for, it is bidirectional, right? And we have some clock, okay, or we can say clock buses, okay. So in case of SDR, SDRAM, we can read and write one time in a clock cycle. That is the definition. That is the key point, right? In a clock cycle, we can write only one time. Okay, so that means, and from that definition, we can figure out what is the disadvantage. The disadvantage will be, let's suppose we have to write again or read again. Then we have to wait for the particular time like till the clock cycle will end. Okay, only then we can read or write, we can do the read and write operation, right? This is what, and to solve this problem, there comes DDR. Okay, so that means like in case of DDR and on clock, what we have one rising edge, one falling edge, right? So that means we can either read or write the data on the falling edge as well as on the rising edge of the clock. Okay, that's why it is twice, right? So here I just want to mention few parameters, and I'm not going to mention the definition here because you'll have recording at the end. So in case of DDR, what will be the data transfer rate? The data transfer rate will be in the range of 266 mega transfer per second to 400 mega transfer per second. Okay. Now, why I'm using this term mega transfer per second? Why I'm not using megahertz or something like that? So again, the mega transfer per second, here I'm not talking about the complete data bus. Here I'm talking about the single line that is connected, single bit that is connected between the RK3399 and the RAM, right? But you can't say this is our maximum data transfer rate or the bandwidth, because the bandwidth will be calculated for all the data bus or data width. Let's suppose we are using 16-bit RAM, right? So then the data transfer rate will be this multiplied by 16. Okay, and that will be in bit. So for byte, we have to divide it by 8. You're getting my point? Now what? So this is double data rate. right? So if I'll ask one question, and this will be like really simple, I hope you people can answer this one. What will be the clock frequency if we have data rate of 266 mega transfer per second?
133 megahertz.
Correct. It will be the half of this one because the data rate is doubled, right? So it will be 133 megahertz, right? Now, if I'll ask, I'm just asking one more question and then we'll move to DDR2. Now, here if we have to calculate the bandwidth or the maximum data transfer rate, right? And the processor and the RAM that we are using, it supports 32-bit of data width. Okay. Now, what will be the bandwidth? And the clock frequency is 133. So it will be 133 mega, obviously, into 10 to the power 6. So I'm just using mega, multiplied by 2 because we have double data rate, multiplied by 32, right? Because now we have 32 data lines which is connected between the processor and RAM, right? And divided by 8. So this will be in byte. Okay, like megabytes per second. Okay, so because I'm using term mega here, so that's why it will be like byte per second. Okay, so this will be our bandwidth of a particular processor and SDRAM. Okay, let's move to another point. Now here one more thing. So with time, when our standards, so generally for DDR we follow JEDEC standards, right? So when JEDEC standards improved and they kind of developed better interface between the SDRAMs and our processor. So one more thing that they've improved called the power consumption, right? So during the time when they developed DDR, the voltage they were using, so the voltage was 2.5 volt, right? It's very, very, very high voltage, right? But when they developed DDR2, the voltage reduced to 1.8 volt. Okay. You can see what will be the voltage in case of SDR. You can search for that. Now, what else they have improved? They have introduced a new term called prefetch bit. Okay, prefetch bits. And in case of DDR2, this prefetch bit is 4n, 4 times of a single SDR, right? So you can say here the multiplier was 2, but in case of DDR2 the multiplier will be 4. Okay. Now what is prefetch bit? What is the meaning of prefetching? Is it something related to prediction or something like that? How? So again, I'm just going to tell you a simple definition of this one. So again here, what is the key difference between DDR and DDR2? The power consumption. We have reduced the power consumption by decreasing the voltage, and we have kind of speed up the processes, right? So prefetch data. So like during the how it is speeding up the process, it's kind of prefetching the data before its requirement, and it stores that data on the SDRAM. You're getting my point? Or sometimes in the cache memory. It depends on the keywords that is available on the data, right? So, and that prefetch kind of increased when we'll talk about DDR3, DDR4, DDR5, right? LPDDR4, it is 16 times, right? So I hope you got what is the meaning of prefetch. It kind of prefetches the data before its requirement. So in one clock cycle, it is reading the data 4 times. You getting my point? So that data bit can be 0.
No, I didn't got your point. What do you mean about prefetch? So I bring the data from the DDR before I require it, or what is it, prefetch bits? Can you explain it again?
Yeah. So again, let's suppose, so you have a processing speed on the processor, right? And what happened, there is communication happening between the RAM and the processor, right?
Right.
Right. And what we do in case of DDR2, we kind of read the data 4 times in a clock cycle, and we store that on the SDRAM. When the data requirement occurs during the operation, it just read the data from that memory or cache memory and perform the operation. You're getting my point?
Okay.
It's not
So we
happening
just
kind of real time.
put it in the cache. Okay.
Yeah.
Okay, got it.
Yeah. So this is how they figure out. Okay, this is one thing, and with time they kind of increase this multiplier, and they reached up to 16 times in case of LPDDR4. So in case of LPDDR4, the multiplier is 16, which is like really huge. If you calculate the maximum data transfer rate or bandwidth, it will come around 100 to 200 Gbps, right? It is really huge. And again, with that thing, kind of difficulty is increased for the designers, and we have to follow more. We have to kind of design a very ideal board, right? We don't have a lot of scope to play with the tracks. We don't have a lot of scope to play with the design rules, reduce the clearance, all of those stuff. We have to stick to the impedance planning and everything, right? So that is one thing. Let's talk about DDR3. And so here, range is, if we'll talk about what is the speed, so you can multiply that. So in case of 133 megahertz, the speed was 533, right? And it can vary up to 800 mega transfer per second. Okay. Let's talk about DDR3. So on DDR3, again, it is obvious they reduce the voltage. They reduce the voltage to 1.5 volt. Okay. Apart from reducing the voltage, they've also added few feature on the SoC itself, and that is ASR and SRT. Okay. Sometimes people ask those during the interviews and all the stuff. So that's why I'm discussing this. So what is ASR? And its name, as its name says, it is automatic self refresh, right? So why we basically refresh a particular memory, or why we refresh that? Anyone?
I would say to clear up the memory, but that's just a guess.
Yeah, I mean, for refreshing a RAM, I mean, it will clear the memory. That is one thing. But here the purpose of refreshing a memory is power consumption, or you can say heating. So you can relate that with switching regulators. So like when we have switching regulators, we can, able to transfer high amount of current as compared to linear or LDOs, right? So similarly, they have introduced this feature to kind of lowering down the temperature, right? And these both features are related to the temperature or the power consumption, right? Or the heating of the chips, right? So self refresh, one is automatic refresh, another is self refresh temperature. So again, the meaning is same. If memory's temperature is kind of increasing so much, its refresh rate will vary, and obviously it will increase, right? So this is one thing. Sorry, it will decrease, right? So this is one thing that they have introduced in case of LPDDR3. Let's move to another version, which is again very important, called DDR4. Okay. So again, they have reduced the voltage. They have reduced the voltage, and it's 1.2. Okay. And what will be the multiplier? Anyone?
16.
6N. Yeah, it's 6N. But apart from that, they have introduced few more features on this one to save the power. Because on early days, the processors, like one thing, it was heating too much, right? The power requirement or the power supply, because things are going very compact right now, right? And everyone we can't able to remove batteries, right? We don't have something which will never discharge, right? So what we can do, we can basically reduce the consumption of battery, right? And what is the most power consumption unit in our laptop, mobile phone, and everywhere? Because we are doing lot of processing, right? We are running very big applications. We are doing lot of processing, and to run those applications, software needs more power. Hardware needs more power, right? So they figured out one thing that they called data bus inversion. Okay, data bus inversion. Okay, I'll discuss that in very detail during the discussion of LPDDR4 with some diagram and everything. But here I just want to introduce, so things will be familiar for you, and yeah. So again, data bus inversion is nothing but they have inverted the data. So for example, when we have to detect one, how we detect one? That means there is some power which is coming on the line. Agree? That means if we have to detect one on a simple microcontroller board, that means there is some 3.3 volt or 1.2 volt is sinking on the processor or something like that. Agree? Now let's suppose, what is the meaning of data bus inversion? So they have figured out if in a data byte the number of 1 will be greater than 5, then they will invert the data bus. Okay, so what they do, let's suppose we have this byte. So here we have 40 and 41. That means here DBI will not work. Okay, there is no DBI. Okay, let's take another example. We have 6 1 and 2 0. Now what data bus inversion will do, it will convert 1 to zeros and zeros to 1. Now what is the advantage of this one? There is no sync current flowing from power supply to processor or memory, right? And this is the and that's why DDR4 RAMs become so popular, and everywhere like people were using DDR4 RAMs. I'll show you the circuit in the next session, because today we don't have that time. I have to discuss few more topics. Okay, apart from that, they have integrated few more things, and those things are related to redundancy check. So why we do redundancy check? Anybody?
To make sure we got the data right.
Right. Because see, during the transmission, there are a lot of stuff on the line, right? What are those stuff? Between the processor, like what is the real flow of signal? I can draw that. It's really interesting. So let's remove this. Okay, what is the real flow of signal? Maybe you people saw that on ESPI course. So we have driver. After driver, we have package. After package, we have board. On the board, we have lot of vias. Then again, we have board. Then we have another package. Then we have receiver. Right? So between transmitter and receiver, we have lot of things which can affect the signal, which can affect our bit. If we are sending 0, maybe due to some noise or bad signal integrity of a signal, maybe we are getting 1 here because of some oscillation on the line, because of some false triggering, anything, right? And this is the whole thing that we have to do. And after designing a complete board, we are doing this wrong, right? So to solve this problem, they have developed few algorithms, you can say, or few algorithms that they've implemented on the hardware level, right? And that is the cyclic redundancy check, right? You can read about it in very detail. I'm just going to mention that. Okay, so they have integrated CRC on DDR4. Okay, now this is one thing, and apart from CRC, again, error detection. For error detection, they have also integrated a parity check for command and address line because these lines are very, very important, and these lines are common if we are dealing with multiple ranks of memory, as I already told you. So for this one, they call that CA parity check. Okay, so you can read about it, parity check. It's like again, it's related to error detection and everything. That is one thing. Apart from that, yeah, that is all about DDR4. Then again, another version comes which is DDR5, and then another version comes which is enhanced DDR5, right? So before, we're not going to discuss everything here, right? So things are very similar. They have integrated few new things on that one. They have multiplied the prefetching bit, and data rate will increase, right? They are dealing with high clock frequency because they have lot of inbuilt algorithm which kind of provide more freedom to the designers so they can route things on the board, right? Things are not very ideal. We can design those in the real world, right? So let's move to another variant of double data rate, and that is so this was the SDRAMs. Now we're going to talk about the MDRAM, and MDRAMs are mobile double data rate. Mobile double data rate SDRAM. Okay, what is or we call that LPDDR4, low power not 4, LPDDR. Okay, so as its name suggests, low power double data rate and mobile data rate, right? So we will discuss that on the next session.